All right, so I got an email request to work on a problem today, so let me go ahead and get that one started. Two questions. First one is number 8 from the half-life problems. So let me bring that up on the desktop so people can see it. So how long does it take for the mass of 157 grams of 259 niobium to reduce to 223.5 grams if the half-life is 58 minutes? So to solve this type of problem, again, we're just going to start with a half-life formula. N equals N naught, 1/2 to the T over T 1/2. N here can refer to atoms, it can refer to moles, it can refer to grams, it can refer to basically any quantity that can be connected back to atoms. So we have mass, moles, everything gets back to atoms. So if we start with 157 grams and we finish with, let's say, 23.5. And we want to know how long that took given a half-life here of 58 minutes. Then all we need to do is turn around and rearrange and solve for time. So we're going to divide both sides by the 157 and take the natural log of both sides, and this will give us T over 58 natural log of 1/2. And if we just rearrange, we get natural log of 23.5 over 157 divided by the natural log 1/2 equals the time over 58. So we're just going to multiply the whole thing by 58, and that'll give us the mass. And in this case, we've removed over half the mass, so we should be at beyond 58 minutes. In this case, it ends up being, looks like 159 minutes to get to this time. The other request was for the Nernst equation. So let's do the second one on that problem set. Give me just a minute to transcribe this to the board. So we've got water. Well, it looks like hypobromic acid plus cobalt goes to bromide and cobalt hydroxide. And you're being asked three things here. What's the standard reference voltage, E naught a cell? What's the number of electrons transferred? And what's the actual voltage based on these conditions? And the conditions here are 0.005 molar NaBr, 0.200 molar hypobromic acid, and then a pH here of 4.55. And your temperature here is 35 degrees C. So to solve this type of problem, first thing we need to do is find the reference voltage. The Nernst equation itself is E of the cell equals the reference voltage, E naught a cell, minus RT over NF ln of Q. Now, if you go through the practice packets, it asks you for Q first. I didn't do it in these types of problems just because Q typically takes on these huge powers of 10. It just kind of skipped you needing to find, like me having to worry about you programming and what Q is. To figure out the reference voltage, there's two tables on the course website. So let me bring you over to the lessons ribbon in the course website. The one you're going to be given for the final exam is this final exam formula sheet. If you download it, it's got just a select few reference voltages by voltage and by potential. The one you need for the homework is the table works its way to more negative. They're the same information, and you're going to see the same thing on those test forms, is that there's two tables. It's the same information, just one's organized by the element, the other's organized by the voltage, just to make it easier to see which is which. So in this problem, we've got hydrobromic acid. So if we go to bromine in this table, you've got this HBRO, goes back and forth to BRO minus, that's 1.311 volts. And then the other one is the cobalt going to cobalt hydroxide. And I definitely made a mistake of not looking far enough down this list yesterday when I did, so I'll make sure I do it this time. So you've got chromium, Cobalt hydroxide, this is minus 0.73 volts. So to figure out the cell potential, E naught cell, what you need to do is the reduction reaction minus the oxidation reaction. The reason is that this table shows only reduction potentials, and if you notice the oxidation reaction is reversed from what you see in these tables, that's because this is an oxidation reaction. What's written there is reduction reaction. So what ends up happening is that we switch the sign on it, which is how we get this relationship. It's E reduction minus E of oxidation. Technically, we're adding the negative of the reduction form of the oxidation reaction, so this just kind of like makes the math a little bit easier. The reduction reaction, we have bromine going from +1 to -1, so this is our reduction reaction, it's 1.331. Our oxidation reaction is cobalt going from a 0 to a +2, so it's minus -73.73. Negative minus the negative is going to give a positive, so it's 2.061, and it asks for it in terms of just 2 decimal points. So this would be 2.06 volts. Next thing we need is Q. Q, you should already know how to do this from like the past 2 tests. It's the concentration of bromide over the concentration of HBr, hydrobromic acid, or hypobromous acid. So you're given those concentrations. If there was an H plus or OH minus, you'd worry about the pH, but don't try to force an information if it's not there in Q. Q doesn't have H plus or OH minus, and that's the only thing that connects to pH. So this is kind of like hearkening back to the exam you just took. So if you stick these in, you will get a number. That number is going to go in the value for Q. Temperature is 273 plus the 35 degrees C. R here is 0.008314 kilojoules per mole Kelvin. The number of electrons transferred, this case is pretty easy. This goes from a +1 to a -1. So that's 2 electrons because there's only 1 bromine atom. You can see that with cobalt. Cobalt's going from a 0 to a +2. There's 1 cobalt atom doing it, so it's +2 times 1. So our number of electrons is 2, and Faraday's constant is 96.485 kilojoules per volt electron equivalent. So at that point, you just stick everything in, and the number you should be getting back is roughly 2.1 volts. There's a little bit of play in that. Generally speaking, you should not see your voltage shift that far off of the reference voltage, like maybe a half a volt, and that's for like really extreme cases. This is kind of the joy of batteries, is that the voltage really stays pretty constant throughout the life of the battery. It's not until the battery really gets to its last legs do you begin to see the voltage really substantially drop down. So if any of you have ever had to replace a car battery before, or you've ever had your car battery diagnosed, they'll say like the battery's about to give out, but it still operates just fine. The reason being is it takes this natural log relationship. So what happens is it doesn't move very much, and then when it gets close to the end of its life, you start seeing this shift away from the reference voltage. Your lead acid battery is going to be roughly the voltage of a lead acid battery at 1 molar everything. The reason the concentrations are so far off is basically increase the capacity of the battery. But definitely it's not until the battery is like on its very last amount of reactions when you begin to see that voltage shift radically away from 12 volts. So those are the only questions I had that were asked in advance. Any questions out there from anyone watching? Just a fair reminder, tomorrow pretty much everything is due. Your lab notebook is due, homeworks are due, your lab assignments are due. You've already seen I posted the quiz grades. We don't really have any quizzes left. The lab exam is 90 minutes long, so you start it, it'll be a timed exam for 90 minutes. It's very much going to harken back to the labs that you've done this semester, so make sure you've got your Excel sheets handy from any calculations you did. Make sure you've got your lab notebook handy just so you can see what you did. But it's going to focus more on the data processing, so like mock data being applied to just making sure you know how to go back and do the analysis. Right now, I'm getting things set up so this way Friday morning when all the homeworks are due, when everything else is due, I can spend Friday morning getting all the grades in. By midday Friday, you should see your lab grade and your homework grades posted to the course website. At that point, the only grade you have outstanding is the final exam. I'm probably going to accept whatever your final exam grade is. The final exam, I do go through them to make sure there aren't any errant questions or it's not marking you wrong for things that are correct. Generally speaking, though, that partial credit is already built into the responses. So if you're getting a wrong answer, it's typically because there's a predictable way that you can make mistakes in these problems. So particularly the multiple choice comes from problems that have multiple concepts being tested at once. There are ways to get those multiple choice answers if you're not understanding all the concepts. The only exception to this are like knowledge-based questions, but even then, those really don't have partial credit. That said, not all the multiple choice questions weigh the same, and you're going to see this when you take the exam. The questions that require more work count for more points. That's where the partial credit comes from. Something like, what is the definition of this? That's worth only a point, but something that says, okay, go through and do these 3 tethered calculations, that's going to count for a lot more points, but there's a lot more opportunity for partial credit with those questions as well. And again, it's 35 questions multiple choice. You get an hour and 50 minutes. You should see once you submit your exam, that's pretty much going to tell you what your grade is. School does not grade a decimal point, neither do I. So if you have something like an 89.5, that will get rounded up to a 90. If you got something like an 89 or 89.4, 89.3, you might be able to negotiate going up. That said, Monday I'm not going to really hear those emails. I'm not going to really respond to those emails. The big reason is that Monday by 5 p.m. the semester is over and I have to submit your grades. Now, they are technically due Tuesday at 10 a.m., so you will see that if you look at the resources from the school. The thing is, that's the deadline for the grades to make it to the registrar's office. That is not the deadline for the instructors. Technically, the instructors can submit your grades by 10 p.m. The problem is that every instructor will be submitting their grades Monday afternoon. We won't know until Tuesday morning if the grades didn't go through. So my plan is to submit your grades Monday afternoon to make sure that they do go through. And if there's an issue, then Tuesday morning, I can resubmit the grades. But generally speaking, if you ask me Monday, hey, I didn't quite get the grade I wanted, I'm probably not going to have time to respond to that email. But yeah, we are in the home stretch. This is the second to last live stream. Also, those of you who are not at Wake Tech and are just taking this over the summer for credit and are going on for organic, you might really want to look at Wake Tech, and I don't say that just because I teach at Wake Tech. We're doing hybrid organics this fall, so you do physically have to show up for a lab, but that's the only time you physically show up. The labs are 3 hours long, and it will just be you in a room with 8 people plus the instructor, so everyone gets their own lab bench, they get their own kit. This is how we're responding to COVID. We believe that organic really needs to be done in person, but the instruction does not. So if you are looking to go organic, I'm going to pitch against state. I still don't know what state's doing for organic. They've been kind of wishy-washy on what they're planning on doing, but we have a plan. It's something you might want to consider. We're doing both Organic 1 and Organic 2 this fall. And I will push it because we are trying to expand our organic program. We would like feedback on how to make our organic program better. Quite frankly, I think we can steal from state, but we won't know until we know what we're doing right and what we're doing wrong. Other questions out there? During the state of matter, we're looking at an element in a reaction. So I'm guessing you're talking more about the solubility. So there are solubility rules and there are insolubility rules. Solubility rules always win. The insolubility rules are kind of unless there's a solubility rule, we definitely know it's an insoluble. And if we don't have rules for either, just assume it's insoluble, because you can always say, well, it's maybe soluble, but it's not that soluble. So for the solubility rules, so your column 1 metals. So sodium, lithium, potassium, rubidium, cesium, if those are present in the compound, it's definitely going to be soluble in water. It doesn't matter what it's bound to. Ammonium, NH4+, is also another excellent way of getting something soluble in water. And these are both cations. In terms of anions, we've got nitrate, chlorate, what's the other one? Acetate. So anything bound to these ions is definitely soluble in water. Now, we have 2 others, chloride, bromide, and iodide. These are all soluble in water except for lead, mercury, and silver. So lead chloride, mercury chloride, silver chloride, bromide, iodide, those are insoluble in water. Sulfate, SO4 - 2, soluble in water except for lead, silver, mercury, same as these, plus calcium, barium, and strontium. Now again, when we say insoluble, you're going to find KSPs for all of these. So calcium sulfate is what makes hard water hard. It's somewhat dissolved in water, but again, this is why we kind of can use well, if it doesn't have a solubility rule, we can just pretend it's insoluble, because it may just not be that soluble. In terms of insolubility rules, assuming they're not bound to one of these ions, hydroxides are generally insoluble. Phosphates are generally insoluble. Sulfides are insoluble. I'm trying to remember the rest of the list. Carbonates. And there's a few others on this list. And yeah, if you have any low valence polyatomic ion, so something like a nitrite versus a nitrate, the lower oxygen polyatomic ions are generally insoluble. The reason being is that these act more like molecular bonds, like covalent bonds, than they do ionic bonds. So what you would do to figure out something is soluble or insoluble, if it contains one of these, it's definitely soluble. If it contains one of these, it's definitely insoluble. If you don't have anything to go off of, just assume it's a solid, understanding it probably has some degree of solubility associated with it. Now, in terms of the homework grade, so those homeworks all have different numbers of points. And what I do is I generally look at the homework that hurts you the worst, or the one that costs more points. So if you look at the redox balancing lab, that's like 40 points because there's a lot of work that goes into it. If you only get like 10 points on that, so you get like a 25%, that will be the homework I drop. Whereas like if you got like a 25% on like a 10-point homework assignment, like you lost 7.5 points on that versus the 30, I'll drop the one that you lost 30 points on. But it's all the points you got divided by the total number of points in the semester, with the one that hurts you the worst being removed. So generally your homework average is going to go up about 1, maybe 2% from what you see on WebAssign. And yeah, that's how that's going to work. I generally don't advertise the drop at the beginning of the semester just because I don't want you kind of banking on it. I want you to do all the homework. Then it's also kind of why I only counted as 2.5%, so that if you get it wrong, you're not as worried about it. But yeah, typically most students by this part of the semester are just burned out, even in regular semester. So that whole big fat redox homework, dropping that is usually what students take because it does count for so many points. And again, I can see definitely like dropping one assignment for you. Like maybe you just had a bad day or you just didn't get to it. But that's how the homework grade is calculated. So the vitamin C lab where you actually do a redox titration, that'll be on there, but the one where you like did the online problems where you balance redox, that doesn't need to be in your lab notebook. That's a paper notebook. That's a paper lab. You're welcome. Have any of you had trouble logging into Blackboard today? Yeah, it's not showing me updated announcements either, and it's really confusing because I can see the announcements on my side, but when I log in as a student, I can't see the announcements anymore. Or even when it shows me only a handful of announcements. But I got a student saying they don't even see the course anymore. And they're definitely enrolled on my end. Yeah, for the past couple weeks, it's also not been telling me my announcements have been going out. But again, it's weird because I see it on my end. And like, I see where it said it sent it out, but I just don't see it. Cool. So this fall, you can actually purchase face masks through the bookstore with financial aid. Sorry, we just got the guidelines for this fall. This is really kind of interesting. Well, I will hand it to them. That's actually a pretty good policy. That's why. Okay. Yeah, I just need to be able to see what. So the question's been asked about PowerPoint theme. I'm guessing so you can put up the lab notebook. As long as I can see what's in there, that's more important. So I'm more focused on your lab notebook than the actual presentation itself. those of you who are watching the videos, I'm responding to email questions as well as the visual questions. So email questions are more people asking about their individual work, which I can't talk about because that's a violation of FERPA. I can't tell you what other people's grades are. So it's kind of why we're doing this kind of weird back and forth with the keyboard and also talking to the chat window. Give me just a minute. Even better. currently in the process of repairing an antique radio, and I have never seen a 2100 ohm speaker before. And to put it in context to you, most speakers, like even in your car, are like 8 ohm. And it explains why there's a transformer on the back of this stupid thing, because I'm sure it requires some absurd amount of voltage to make this thing work. But I'm really curious now. Weird. Alright, so I'm not seeing a lot of activity in the chat bar right now. So we'll go ahead and start closing up shop today. Tomorrow is the last live stream. Please come to me with other questions you have. Yeah, again, make sure you get everything in tomorrow. I'm not likely to grant any extensions. Again, the big reason is we kind of need to close out the semester. So I need to get the homework graded. I need to get everything else put in to make sure that y'all are pretty well informed about what you need on the final exam, and so we can get the grades in quickly on Monday. So I will see, please again, feel free to email me any questions. I'm around via email, and I will see you tomorrow for the last time. Thanks for showing up.